Okay, now it should be working. Let me. Um, cool. Looks good to bacon. All right, I think I got it. You can hear me all right? Cool. All right, I'm gonna get started, and hopefully some more people will jump on. Let's hope I won't do any more tests. Yeah, sorry. That was kind of annoying. Probably more so for me than it was for you. What did I change this time around? Well, this, I guess for you it's like right here. There, right? The YouTube chat overlay was not synced with the second stream. Um, and so I brushed my hair. No, I didn't. Uh, so I had to restart that. So it was kind of annoying, but it's all right. We're ready now. So I'm gonna just jump right in and get started. Gonna make this bigger. Assignments. All right, so we had done, oops, Stirland, right? And it was working. And then we also did Prinster, and it was also working. And I sort of made my own test right down here, because we didn't want to use the Python one. So I think we pretty much just have to keep going along, doing these functions that we need to write. So first, that's going to be print char. Hello, Astro. Thanks for joining. Sorry about the technical issues I was having earlier. Except I think it might have saved those test streams to the playlist, which is not good. So I wonder if I could delete those really quick. Let's see how long this takes. Live, select, more actions. Delete forever. Okay, that was easy. All right, now those are gone. Cool. So this is looking good. And now we need print char accepts a character code directly as its first argument and prints it to standard out. So it's just like print string, but instead of taking a pointer to an alternated string in memory, it will just take directly a character. Okay. That seems not too hard. Let's start with copying print string. And then we'll do print char. No? Yeah. I could also do a pointer. But it says accepts a character code directly as its first argument, right? So yeah, just a pointer to a char. But isn't a pointer to a char like the same size as a char? so there's not really much point in that. Keep the good work. Thank you. All right, so how are we gonna test this? First of all, we need like a we need a character. Like, what's the ASCII code for the letter A? Lowercase a is 97, so we'll just try that. Could I just do like this, 97? Or I guess I don't even need that. I could just inline it down here, couldn't I? So we'll say move. Wait, let me copilot disable. Whoa, Xylo, you're blue and you have a wrench. It's probably because of those permissions I gave you yesterday. Although they still didn't work, did they? Alright, so I'll move RDI into RDI 97, was it, or 93? Oops, it was 97. Okay, 97. So that should be A, right? Lowercase a. And then we're going to call print char and try to print that thing out. So I need to recap. First of all, I was having some serious technical issues, so this is like the third stream. But second of all, we're just doing print char, because yesterday we did print string length and print string, and I'm doing print char. And so it just takes a character code directly as opposed to a pointer to a null terminated string in memory. So 97 is the ASCII code for the lowercase a, so I just move that into RDI, and I'm calling print char. Should print out lowercase a, and then I'm going to exit. Now I need to write the function right here, although it'll be pretty similar now. So I'll just do print char. You can do man ASCII to see the whole table? No way. Who knew? Where's this window going? Man ASCII. This is kind of... Oh, cool. Sure enough. That's really neat. Okay. Yeah, man pages are the best. Hello, the Atom64. Alright, so we got print char. We don't need to do strlen because we know it's got a length of 1. Oh yeah, and then some of this is just... Alright, so maybe I'll just do it from scratch. So I'll move into RAX1 because that'll say print. Then I'll move into... See, some of these I need to... Where's that easy print? Hello, Dadasm. Okay, like this kind of thing. That's what I forget. Okay. So move, this says write syscall. This is the write syscall. RDI. This is to standard out, right? This is the length of stir, which is just going to be 1, right? Because it's just a single char. Hi, cat. And then we're going to print the message, which is actually going to mean RDI. So first we need to do this up here, right? Because we're going to then corrupt RDI right here. Move it to there. And then don't forget syscall and return. We searched online for an ASCII table. Okay, and I'm thinking this should work. Let's try it. Assignments. Alright, let's do we still have that like just run what is it? Print char. It didn't exactly show the output. You could always just memorize it. Not a bad idea. Okay, let me just try this the old-fashioned way. nasm-f elf64 print char.asm-o print char.o, then link print char.o-o print char, and then print char. It's not printing anything. Okay, so clearly we have some problems. Remove 97. Debug strace. Okay, move 97 into RDI. Then we call print char. So now 97 should be an RDI. Then we move it into RSI. Then we move 1 into RAX, 1 into RII, 1 into RIDX, because this is for write, this is for to standard out, this is for the length of the string. Syscall and return 97. Is it 41? I don't know. Where'd my other thing go? This says 61, but this is in hex. Here's decimal. See a lowercase a in here somewhere? Oh, here we go. Yeah, 97. Or OX61. Which we could also do, right? OX61. Okay, this isn't working. So debug it. Since we know how to do that now. Yep, not working at all. Hey, again, can't see the name of the textbook I'm using here. This is, how can I do this without losing my spot? It's called low-level programming. It's here, right? I'll show it. Not that one, this one. It's like a low-level, this is like the repo for it. Low-level programming by Igor Zhirkov. I don't know how to pronounce that, but it's this. So okay, let's debug it. So we're gonna do the same thing, build it again, but this time with debug symbol. So dash F dwarf, and then link it again. Okay, and then I'm going to LLDB. You're very welcome. Print char. Okay, and now I need to set a breakpoint. No, so I'm gonna put one. Oh yeah, no, we just do this thing like breakpoint set dash name underscore start, and then we run, and then we're in here. Okay, so RDI should have OX61. So if I register read RDI, we have sure enough 61. Cool, which is actually 97. And then we stat, and it jumps into print char, and it already did the first line there. So we should now have this 61 was an RDI, and then we move it into RSI, so they should both have that. So if I register read RDI, it should still have that, but so should RSI. Sure enough, this is the case. Okay, so now now what? Okay, so we'll step again. Oops, step again. Now we just moved 1 into RAX, so if I register read RAX, It has 1. If I step again, RDI now should have the same. Yep, but RSI should still have the 61. Cool. And now we step again. And we got moved 1 into RDX. So RDX should also have a 1. Cool. And then we syscall. So we syscalled. And then we step again. We return until we come back out here. And then, right, so everything seems to have worked. It just never got printed. Oh, is it because... Oh, I have an idea. So before we were doing stuff like this, when we were doing entire strings, we did like data, and then we had some like constant up here, like foo or message was like lorem, right? Null terminated. 41 versus hexadecimal value for ASCII character. That's capital A, but this is lowercase a. Silo left to get some food. Nothing really happened. It just doesn't work. I debugged it and it seemed like it went through the right steps. But I have an idea. So before we were doing this, right? This kind of thing with entire strings, and then we were passing into here like message, right? Message is a pointer, no? That's why I remembered it being 41. Oh, okay, gotcha. And so this is a little different because this, like, my question is it treating... RDI contains the actual ASCII code of the character, but is it treating this as a pointer instead? And, like, pointing it into some memory? That's not a character, right? Because that would explain why it's not working, I think. How can I make it not treat this as a pointer? Does that make sense? LEA. I remember seeing that guy. Or could I... This is just an idea. Could I, in theory, like... Load effective address. Yeah, what is that? What exactly does LEA do? In the meantime, could I do something like push RDI and then use the... Because then would the stack pointer be pointing to this? And then I could use it here? What's the stack pointer again? RSP or something? Loads the content of the pointer. But I want to do... But I don't want to load the content of a pointer, right? I just want to use a raw. I just want to say use this value as the value and not as a pointer. Does that make sense? So, here, wait, I've got a question. Does the stack pointer point at the most recently pushed thing? Points to the top of the stack. Where's the location? Which is the location of the most recently pushed item. However, it's important to note that the stack goes downward in memory. This means that when you push a new item, oh dear, I can't scroll. When you push a new item onto the stack pointer is recommended to point to the new top of the stack. Okay, yeah. It should be loading the value, not a pointer. Can I try this? If I push RDI and then do this, do you think that would work? Yeah, 97 is stored in the register, exactly. Not in memory. Do you think that would work? Because then I can treat this as a pointer to where this went. It could work. Cool, let's try it. Hello, offline Mark. You're clearly online. So we NASM it, and then link it, and then, oh, it almost worked. It almost worked. We got an A and then a seg fault. So why are we seg faulting? Exit syscall. I did do that. I did get a seg fault. Push RSI. Oh. Do I need to pop this guy? Like that? Yeah. Okay, cool. Because then that would mess up the call stack, right? The return would then be returning to this location as opposed to the one that got pushed when we did the call. Is that correct? I think that's right. Before ret. Yeah, so this is before ret. Okay, cool. So we'll try that. That does make sense. Oh yeah, check it out. Super cool. Cool. Offline Mark knows his stuff. Thank you, Mark. That is neat. So I wonder, so I could do cool things. Join the Discord. When somebody says something smart in chat, everybody's like, get on the Discord, get on the Discord. I love it. Okay, so that's like 0A. Whoa, we got another OS dev streamer. So I don't stream OS dev. I'm hoping to one day, but right now it's just assembly because I need to learn that first. Right, so this, if I did 0A, isn't that's 10, right? So that would be a new line character. I just wanted to try that. Yeah, we just got a new line. Cool. But I'll switch that back to, what was it? 61. Cool, yeah, so this is our letter A. Awesome, that's fun. All right, so that's 1, 2, 3, and here's print new line. Oh, print a character with code 0xa. Can I just do this one in the same file? Because it's literally just calls out to print char, but with a new line instead. So I'll make a new one because that's what I'm doing. Sorry, I got a little behind on chat. It's cool to see. Thank you. You don't really need to learn ASM first, actually. So you missed a few lies. This is exactly your exam subject. That's in 20 minutes. Haha. Okay. So print new line.asm is going to look very similar, except that It doesn't even need to take any arguments. I can just get rid of this altogether. I can just say print new line. This will just be print new line. And then I want to check out Mark's channel. Offline Mark, what's your channel? Are you called Offline Mark? Oh, look right here. Is this you? Looks like it. Oh wait, I did check this out. Oh, did you comment on one of my other videos? I think you did, didn't you? And you said you were doing the same thing. Because I remember, like, I already watched like half this video. Because I remember seeing this. These thumbnails look familiar. Super cool. Okay. Well, I will subscribe, Mark. There you go. Okay, so I was gonna print new line. So we need to, yeah, it doesn't take any arguments. So the whole RDI dance is pointless now. And then this is silly at this point. So we just need to move. Oh, we do need to get somehow the value 10, which is new line, right? So I mean, we could do like push 10, I guess, and then pop into somewhere like RDI, and then use the stack pointer here. Is there a better way to do this? Is there a better way to do this? Anybody know if there's a better way to do this? There must be a simpler way. That's what I'm thinking too, Astro. I mean, we could ask the AI overlords. So, okay, look. So you know how when you're doing a write syscall, which one is it? RSI holds a pointer to a string in memory. What if I just want to what if I have an immediate value of an ASCII char and want to print that rather than having a pointer to some place in memory? Is that a good question? You need to have a pointer to the character in memory, as the syscall expects a memory address in RSI. If you have an immediate value constant representing an ASCII character, you need to store it in memory first. Okay. Reserve space, move the immediate to reserve space. Use the address of the reserve space. The push is a reasonable thing in your opinion, Mark? I know the push is, it's at least pretty clean. It makes sense. Alternatively, you do this: reserve a byte here, and then do this. Oh, can I just like write character literals instead of these ASCII codes? Who knew? Okay. Well, maybe I'll just stick with push pop. This is a pointer. But we'd have to do this, right? Because this isn't a pointer. Yeah, this. Is this what you're talking about? Yeah. Yeah, that makes sense. But then we have to reserve space up here. Is this cleaner than the push pot? What do you guys think? Hey, can I do a poll? Can't I do a poll? Oh, yes. Did that work? Which is cleaner? All right, reserve space, memory, 50-50. Now it's 40-60. Oh, now it's 50-50. Oh, now it's 40-60. 40-60. It's back to 50-50 for me. Looks like you guys are pretty split on this. Ooh, a poll. Yeah, we need your opinion, Mark. Push swap is more efficient, you're saying? All right. Push pop. We're going to do push pop, even though it still says 50-50. Poll's done. Push pop it is. Avoid allocation at all costs, says Bacon. So we'll do the push pop thing. So this, I guess we're sticking to this stance. So we're just gonna push 10 onto the stack, which is also, I kind of like writing hex. So OXA, right? Push that onto the stack, and then we'll use the stack pointer. And then this should all still work. Print new line. Right, this is also necessary. Make the stir, yeah. Okay. Does writing push? We tried the I think we tried the backslash n and it didn't work before, right? It read it as two characters, like a backslash and then an n. So let's try writing this. So we'll go nasmit, but this is print new line, and then new line, and then we'll link it. And then we'll, sure enough, this is a new line. Cool, super cool. What's next? That's 2 down. Pretty fast, right? What time is it? 7:19. Awesome. Print uint. Okay, this one looks a little tougher. Outputs an unsigned 8-byte integer in decimal format. Stefan, that's a good point. We suggest, all right, you create a buffer on the stack and store the division results there. Each time you divide the last value by 10 and store the corresponding digit inside the buffer. Do not forget that you should transform each digit into its ASCII code. Okay. This is going to be a challenge. Thank you, Stefan, for answering. And Xylo. Okay, yeah, this one's going to be definitely tougher than the others. So let's try it. It sounds fun. uint dot asm. So I'm going to make a global start, and I'm going to make a start. And we know we're going to have to exit, so we'll and then syscall. Right, we know we need to do that. And then we want to write a test here, right? So what would be a good test? We'll probably have some example data, right? So like data, wait, how does this work? Data, no. Oh yeah, this needs to be section text, right? Is that gonna, yeah. And then we have section data. And then we'll do, whoa, viewers are spiking. We'll do, okay. Well, we need like an example. So like a test would be test number. There's elephants. A test number would be like the elephants just got poached. Okay. Test number would be, that's not a good number, like 1, 2, 3, 4, 5, 6. And then down here, outputs an unsigned 8-byte integer in decimal format. So I'm going to move into RDI our number. How do I want to do this? What is happening in chat right now? I'm so confused. Silo's deleting messages left and right. Okay, so we could do like test number, right? Test number. And wait, an 8-byte integer in decimal format. How do I express an 8-byte integer? Like this kind of thing? How can I express an 8-byte integer? DQ. Oh, a quad word. Oh yeah, because a quad word is 8 bytes. Yeah. Oh, thank you. DQ, and then we needed an integer. So 1, 2, 3, 4, 5. All right, that'll be our integer, and then awesome. Then we move it into RDI, I suppose, and then bacon. Figure out what the alpha means. Okay. You don't think I need the colon there? I thought I did. Isn't that what I've done in the past? Maybe not. Oops. Like, yeah, like this. Message colon. Don't need the colon. The colon's here and it worked. You sure? Yeah, it at least works with a colon. Whether or not I need it, I'll try without the colon. Alright, so we move that into RDI. Do I need to specify isn't there like a way to specify like keyword or something here? I don't think I need to do that, do I? We'll try it like this. Both colon and no colon will work. Thank you. And then alright, so we suggest you create a buffer on the stack and store the division results there. Each time you divide the last value by 10 and store the corresponding digit inside the buffer. Okay. Do not forget that you should transform each digit into its ASCII code. Zanbaba. Not sure if I said your name right. Welcome. You're very welcome here. Let me... Alright. So let me make my function real quick. This will be like print uint. So we should, and here we have, here's our strategy, okay? We know in RDI has our test number at this point, right? Then we are going to okay, so we need some sort of like, we need to know what the ASCII codes are, right? So I'll just say like ASCII codes is going to be, I kind of like the colon. I think I'll go with the colon. And then we need to pull up our chart, our handy chart. Find out what they are. So it looks like it's just all the 30s. Oh, this isn't hex. That's fine. Okay, so OX 30 through 39 is 0 through 9. So it's OX 30, OX 31, like that maybe. And then this becomes 2, 3, 4, 5, 6, 7, 8, 8, 8, 9. Switched to ASM. I'm learning ASM. Yeah, if you're just on the day 2 video, I ended up going back and sort of starting over, and now I'm learning ASM. Yeah, I got that. It's like 30, yeah, because 30 is 0, 31 is 1, 32 is 2. So I could just, yeah, so I could just inline that later on, or I could have this table. Oh yeah, you're right. Which one of those makes more sense? Probably what you're saying. All right, we got a good idea. I'll keep that there just in case I end up changing my mind. Okay, good idea. And then I will, so we have that in there. We need to get now, okay. This says each time you divide the last value by 10 and store the corresponding digit inside the buffer. So if we have something like 1, 2, 3, 4, 5, why do you divide the last value by 10? After storing it, keeping me on digits. That makes sense. But I need to like store this 5 somehow, right? So I need to like pop off the 5, store it in the stack, right? Pop off the 5, and then this becomes like a 40, and then divided by 10. So it becomes that, and then I pop off the 4. So this would become a 30, and then I divide by 10, and then I pop off the 3. Is that kind of the idea? And you end up breaking it apart like that. Okay, my question then is, how do I like initially just pop off the 5? Because that's easy to say in English and harder to write in assembly. Check the doc for the div instruction. Oh, it gives you the remainder. Well, that's exactly what I want, is the remainder, no? You do modulo 10, right? But modulo is just like remainder, so I want the remainder. Consider using a buffer at some point. So it would be smart to learn about times in ASM. Okay. So if I could divide this by 10 and get the remainder, then that would like kill two birds with one stone, right? How do I do that? The Does the div command give me the remainder and the result? My long-term goal is to build an operating system. My short-term goal is to learn assembly. Performs unsigned division and provides both the quotient and the remainder. Awesome, but they're stored in different registers. The quotient goes in RAX and the remainder goes in RDX. That's all I need to know. That's perfect. All right, so we're gonna loop through this guy. All right, this is gonna be fun actually. So I'm gonna make a loop label. I'm gonna call it loop. Or don't I have to do dot loop? Okay, then Bacon probably has this copied somewhere. He probably does. All right, it's been helpful though. Thank you guys. And then, okay, so in the loop, we take our number, which is an RDI. We're going to say, what are we going to say? We're going to say, okay, I think I got this now. I just got to think through how to pull it off. So div wait, how do you divide like one thing by another thing? How can I say divide RDI by 10? Oh dear. Okay, this is what I forget. The dividend and the divisor. Which one's which? You need to move the value from RDI to RDX. Ensure RDX is zeroed out. Wait. Is the dividend the top or bottom of a fraction? Dividend is the top part. Oh yeah, because it's the part that gets divided. The number on the bottom is the divisor. Okay, perfect. Thank you. So you move the dividend into RAX. So the top part goes in RAX. Since div uses RAX as the dividend, you need to move the value from RDI to RAX. Then you clear RDX. Make sure RDX is zeroed out before the division to avoid unexpected results, as RDX RX is treated as a... What's this colon syntax it's using? Divisor is the one that divides, and dividend is the one that gets divided. Okay. Set the divisor. Use an appropriate register or memory location, hold the divisor, in this case 10. They made this sort of complicated. I thought it would just be something sort of simple, but it's not. Okay. I don't think it is, because it says it's going to use RDX colon RAX as the dividend, right? Not the dividend over the divisor. Right? Yeah, because RAX is the dividend, which is the top, and this wouldn't be the top of a ratio, right? This is the top. This whole thing is the top of a ratio. Right? Isn't that what it's saying? What's the colon syntax you're using? is used to represent a combined 128-bit value formed by concatenating two 64-bit registers in x64 assembly. This is particularly relevant for division operations where the dividend is larger than what a single 64-bit register can explain. Okay. So the div instruction divides a 128-bit dividend by a 64-bit divisor, which is why you need to combine two different 64-bit registers to create the dividend. Which is why you need to make sure that the top, if you just are trying to use a 64-bit, then dividend, then you need to make sure that RDX is zeroed out so that you don't get the wrong answer, right? And then you just have the tail end being your number here. If it's true, it makes sense. If it's not true, I'm going to be angry at the LLM. So we'll see. You can replace the div instruction with a multiply by reciprocal trick. Yes. How would you don't you need division to make the reciprocal though? Or by cat? Okay, so let's just try setting this up. So I need to, the value I want to divide needs to go into RAX. Excuse me. And then we'll, okay, so move RDI into, move into RAX RDI. And then we need to move, or we need to zero out, what's the one we need to zero out? RDX. So zero that one out, and then we will use a magic constant. What's the magic constant? And then we divide it by something. The thing we want to divide by is 10. Can we just do like div 10? Is that fine, or do I have to stick it in a register? I'm gonna try this. Because for some reason this guy loaded the 10 into RCX and then passed RCX instead of just passing 10 directly here. Not sure why. Hey Mitchell, welcome. And okay, fun stuff. So this then puts, where does it stick the, all right, so now after doing this, so I'm going to comment this, okay? Combine 64-bit RAX and RDX to make 128-bit RDX colon RAX. We don't need the extra 64 bits, so we zero them out, which is that, and then stick our number, which is 8 bytes, in RAX, the lower 64 bits. Learn about it next time. Okay. Mitchell is Dyer from Discord. Okay. And then this, okay, this sticks the quotient, goes into RAX, and the remainder, which is like the modulo, right, goes into RDX. Okay, and then, sorry, yeah, RDX. Okay, and then okay, so then we have this. I don't think I need this anymore. We'll do we'll do what again? Oh yeah. So we have the quotient, we have the remainder. We need to push the remainder. So we'll push. Okay, yeah. So push remainder onto stack. No? By doing push rdx. And then the quotient, which is what we have left, we need to stick into RDI, because then we'll use it again here. So move, or we could just push it straight into RIX. Either one. It would be more efficient to push it straight into RDX, wouldn't it? Move, well, let me think about this. First, let's, okay, and then push, no, move quotient. Oh, it's already in RIX, which is what we want. So we just leave that, but then we want to do this here, and then we wouldn't need to do anything here, right? Okay. Except for that, this should be indented. So, except this kind of doesn't. Lower, here I can lower 8 bytes are already in RAX. See above loop. How long will the stream be today? Not as long as yesterday's. Definitely need to be done before 8:30, but we've been going about an hour, right? I don't know, sometime between 8 and 8:30. Whenever I hit a good stopping point, really. I don't really have hard deadlines. Well, 8:30 is a hard deadline, but I'm probably not gonna make it all the way to 8:30. All right, and then we need to check the so eventually this quotient is going to be 0, no? Okay. At some point we check the quotient to see if it's 0. So then we'll compare the quotient, which is RAX, with 0. Right, I think that's how that works. And then compare RAX with 0. All right, and then so we jump if equal. Jump if equal, so because if Rx is equal to 0, then we're gonna jump to wherever the end is, which is coincidentally located right here. Right, so check if quotient is 0. If so, jump to end. All right, and then otherwise, we'll just jump back to the loop. continue looping. And then down here, so at this point, now we have all the digits in the stack. They're in reverse order, right? Which is what we want, actually. Okay, so now I want to pull in print char almost, right? So I could say, So don't I need to do another loop now? Because I need to pull all those things out of the stack one by one. And print them. So I do need to do another loop. All right, so I'm gonna call this like the div loop. And then since JE is also JZ, can we use that directly from the last div instruction? The proper flag would be set already, no? Ooh, would it be? Like not even needing this and just being able to do this? I like that idea. Is that what you meant? Stream froze. Can you guys not hear me? Is the whole yeah, what about the screen capture? I'm typing stuff. Can you see it? Can't see what I'm typing. Yeah, I think you're right. Wait, Bae, can you see what I'm typing? I can't even see what I'm typing. Okay, let me real quick. Okay, now you see nothing, correct? And then how is this? That's still frozen though, isn't it? That is still frozen. Let me try one more thing, real quick. Get rid of that. Add another one. I'll do that. This one. And how's this? It's working now, isn't it? Working? Am I working? Am I working? Okay, it's good. Thank you. Sorry, well, I really have a lot of technical issues today. Yes, sorry. Sorry. I apologize. It's only my third time streaming, so. Bacon's gonna go make some bacon. Cool. All right, so we have all the digits in the stack. I need to make a new loop. So I'm gonna call this like the what am I gonna call this? I'm gonna call it the pop loop, because we're gonna be popping, or maybe the print loop would be better. No, the print loop, because we're gonna be popping and printing. I could just jump directly now to the print loop, so this probably makes more sense now. Jump to the print loop. Okay. Oh, Stefan said that the flag isn't set by div, so it wouldn't work. Okay, so we do need to do the compare. What did I do? Wait, hold on. Where was it? This thing. Okay. So I'll get rid of that. But it was a good idea. I think it was a good idea. But the flag isn't set. That does make sense. Okay. And then we call this jump this to the print loop. Get rid of that. And this is the print loop. Okay. So now we have a print loop. And now what do we want? We need a, okay. So here's what I want to do. I want to like pop num off stack. Okay. Then I want to print ASCII for num, which is like the OX30 plus num, right? Then I want to rinse and repeat, right? All right, but the question is, how do we know when we're done? So should I like push some sort of flag onto the stack, like up here? Div doesn't support immediate values. Uh-oh. Store 10 to RBX. Is RBX just arbitrary? Like, why RBX? Is there a reason for RBX? This guy had showed, I think, a different register, right? This guy said RCX. You meant RCX, okay. Sure, I can do that. Oops. So move into RCX 10 and then do RCX. Like that. Okay. And then, yeah, so the question at hand is, how do we know when to stop popping things off the stack and trying to print them? And I was thinking, does it make sense, guys, to like push, like if I pushed something, like that didn't, like if I pushed 0 here, well, except I could get a 0, right? But I'll only ever be pushing 0 through 9, right? So if I push like a 10, I'll know. Div register. Okay, thank you. if I were to push here like a 10, I'll never get a 10 here because I'm only getting 0 through 9 as the remainder. So if I push a 10, then here I can check to see if we reached a 10, right? So pop num off stack. If it's 10, quit. Otherwise, right? Does that make sense? So this is like kind of like a flag that I'll just know I'm done if I hit that 10. Not sure if that's the best way to do it, but I think it makes sense, right? Let's just try it. So I don't know what register to use, maybe RAX, pop, RAX. So that's this. So then check if it's 10. So compare RAX with 10. And I would still suggest just having a buffer for the digits because you are extracting digits right to left, but you have to print them left to right. I think the way I have this is correct, no? Because if I have a number like 1, 2, 3, 4, 5, 6, then I'm going to be storing these on the stack. So I'm going to pop off the 6 first, and then the 5 first, and then the 4, right? 3, 2, 1. And then when I go to pop them off, I'm going to get the 1 first, and then the 2. So I'll be printing in the right order. Doesn't that make sense? Let me just try this, and if it doesn't work, then even if it does work, I'll check out what you're talking about. So compare RAX with 10. And yeah, so then jump if they're equal to the end. The end will stick right here. And this is like a to do. Bacon's back. He had his bacon. Jump to the end. Okay, if it is that. But otherwise, we need to print the ASCII. So then we'll say, all right, isn't there like an add command? How does add work? All right, guys, where can I find a good table of I don't need these. Okay, we're gonna find a good table of NASM instructions. NASM instructions cheat sheet. How do you spell cheat sheet? Like that? Like this. These aren't, oh, here we go. Croissant with sausage and cheese and egg. This is sort of working, right? Add destination source, and destination becomes destination plus source. That's easy enough. Okay, so I'm going to, let me keep this open right here. I need to pick a register to keep this value in. How about, I don't know, what's a good register? I could use RX again, or I could use a different one. It probably makes more sense to use a different one. How about, RCX? We have been using that one above, right? What was I using it above for? I was just using it for the div thing. I'll just use it, I guess, here too. So maybe it's a good one to use for math. Move REX into RCX, and then hey Xylo, you sent a link. Does that mean it's working now? REX RCX, and then I will add destination is RCX, and we add OX30 to that. No? Cool. And then so now RCX has the ASCII code for the num. Okay, so now we're gonna pull in. Wow, this is getting complicated. Okay, we're gonna pull in print char so I can comment this out. Because that, oops. That becomes commented out, and then we'll start. All right, and then I need to export or not export, but expose print char, right? And then I will use print char over in print uint. So extern print char. So I probably should have just done this in, because print char expects something to come, yeah, into RDI. So let's just do this math directly into, this is backwards. This is supposed to be RCX, RAX. This one's amazing, he says. Let's try it. This guy? Oh, cool. That is nice. I like that. Where's my ad? Here we go. Ad. Right there on the top. Okay. So I'm going to do this directly into RDI, because that is where we need to have it anyway. And then I'm going to, now we have external print char, so I'm going to call print char, and then once we've called print char, it should have printed the char. And then we'll do it again. So we'll jump to the print loop. Very brave, clicking on links from Asthma Enthusiasts. You'll notice I did it on the other monitor first, and then I moved it up. So, all right, if we, and then print it. So this is kind of our loop. We do 1, pop it off the stack, and then 2, print it. So this is like the pop print loop. Maybe we'll call it that. So pop print loop. And then at the end here, I don't think we'd have to do anything because this doesn't need to return anything. So we can just return. No? All right, the chances that this is going to work, I think, are about 1 in 12. What do you guys think? How likely do you think it is that this is just going to work on the first try? Too optimistic. 1 in 12 is too optimistic. All right, let's try it. Terminal. Oh, I already have it over here. 100% bacon. Yes, that's what I'm talking about. All right, NASM. We already did this, right? NASM. Okay, this is print uint. 20%. Those are both more optimistic than I was. Print uint. LD. Print uint and print. Wait, that didn't work. Sorry, I didn't even look at the output. Print loop undefined. Oh, because I renamed it, didn't I? This guy. It's the pop print loop. All right. Oh, I need to recompile or reassemble print char as well because I removed the start thing, right? Okay, and then I need to link these all together, right? And because print char is also I'm not sure about that actually. Wait, so print uint is referencing print char. Print char is referencing strlen. So I need to do all those together, no? Why does this even use strlen? It doesn't. So I don't actually need this in here. Why was this in here? All right, that makes it easier for me actually. So wait, do this again, and then do this again, and then link them together, right? So print char and print uint, and we'll do it as print uint. Ooh, look, it linked and it assembled. Ready? Do we know what we're looking for here? We're expecting 1, 2, 3, 4, 5. Here goes. Wow. That's amazing. Okay, well, can't say we didn't expect that, right? So, see if we can get this working before 8:30, because then I need to be done streaming. All right, what do you say we debug it? I let down bacon. Sorry, bacon. Yep, it's debug time. We have a very smart person in the chat. Why don't you call the print uint function? That's a good idea. So that was dumb. That was even dumber than my mistake yesterday where I forgot to syscall and return. All right, check it out. Now it's totally gonna work. Print uint is undefined. What do you mean it's undefined? Because for some reason I give it an underscore. Okay. Now link them together again. And then, here's the real moment of truth. Wow. That's not quite what I wanted. 4202496. We were hoping for 1, 2, 3, 4, 5. It did work flawlessly. Yes. Seon said there are tests. We know there are tests. The tests were written in a previous version of Python, and it was causing us much grief. So I decided just to test it on my own. No segfault, at least. And there are numbers. Yes. Yeah, it could be a lot worse. All right, let's debug it. So I'm going to do the same thing. I'm going to NASM it with debug symbols. Dash D, dash big F, dwarf. Wait, dwarf. Okay. That's not good. Oh, because I need to do that. Sorry. Bump this guy over to here. Cool. And then link it. They are updated. Okay. I tried writing them with Python 3 and it didn't work. So wait, Seon has written the book? Wait, what do you mean because I've written the book? I'm a little bit confused. Yeah, is Seon Igor? Or Igor? Or who knows how to say it? You think he's joking? Wait, he has to be joking. The one I'm using, low level programming? Your Igor Zhirkov or whatever the name is? Wait, are you serious? That's so funny. We need credentials. If you are, the book is fantastic. The other Russians are there with him. That is true. No way. Well, wait, I still can't decide whether or not to believe it or not. You sent the link. To the Discord? Hold on. Wait, no way. It's real. This is on GitHub. It's Seon and has low level programming. And teach Kaya. What? Wait, is your on Discord your gene on the bottle? All right, I'm gonna keep going, but no way. Awesome. That's so cool. All right, yeah, thrilled to have you here. Your book is fantastic. I've been really enjoying it. Um, assuming this thing isn't a hoax, but I'm starting to think that it can't really be. So, yeah, your book is fantastic. I'm loving it. Let's try. All right, so what were we? Where were we? Or maybe we should just stop there, honestly. Um, yeah, end on a high note. Thank you so much. Yeah, seriously, I cannot believe you joined this stream. That's so funny. Yeah, okay. Well, I think I'll stop the stream here, right? Next week or not next week. Tomorrow, I think I'm going to do it tomorrow. We'll do some debugging of this which isn't working, right? So, we'll debug this. And yeah, we'll go from there. Starting tomorrow. I'll be back on tomorrow. But thanks everybody for getting on. Thank you, Igor or I think Igor. Not sure how to say your name, but thanks for writing the book and for joining the stream. Honor to have you. See you guys on Discord and tomorrow. So.